Welcome to the debate. Right now, Fortune 500 companies are pouring billions of dollars into artificial intelligence and, continuous compliance, only to find out that their state-of-the-art digital invoices are basically invisible to machines.
Yeah, it's a massive blind spot.
It really is. I mean, we have this collective assumption that a pristine PDF invoice, beautifully rendered on a screen with every tax code and line item, we think that is the pinnacle of digital finance, but it is not.
No, definitely not.
To an automated compliance engine or, say, an enterprise AI model, that PDF might as well be a photograph of a cloud.
Right. And that dangerous assumption that digital data and machine-readable data are the same thing is exactly where massive technology investments are currently just bleeding out.
Oh, entirely.
Because moving from paper to PDFs or standing up a massive internal database, it feels like modernization, right? But human-readable text on a screen does not give an automated system the structured truth it needs to, instantly consume and act on that information.
Exactly. Which brings us to the central architectural question we're tackling today. Since governments are now machine-reading financial data in milliseconds through continuous transaction controls.
Milliseconds. It's incredibly fast now.
Right. And since enterprise AI requires absolutely flawless data to function at all, where must the architectural burden of machine readability actually reside?
That is the million-dollar question.
Or billion-dollar, really. So my stance is that true machine readability, specifically the principle of contextual completeness, it can only be achieved if it's strictly enforced as a design constraint at the absolute source of data creation. And that means the core ERP system.
Well, I come at it from a completely different way. Regulatory requirements are shifting globally at just a breakneck pace, which is significantly faster than legacy source systems can ever adapt.
Sure, but
Because of that reality, the true strategic center of gravity, it cannot sit in the ERP. It has to reside in agile, externalized orchestration layers using a canonical data model.
okay, let me explain why the source system is the only logical place to anchor this. I mean, the defining characteristic of machine readability isn't just having the right file format, right? It's contextual completeness.
Right, the data actually has to be there.
Exactly. And the source material we're examining draws a very hard line here. If a transaction record is generated, but it's missing, say, a specific tax code or a business partner's VAT number,
That it's useless to the machines.
yes, no downstream compliance system can process it without human intervention. That is a hard stop. So if that invoice is generated in the ERP without those required fields, an external software layer cannot magically invent a genuine business fact that was never captured.
I hear your point on completeness, but I'm sorry, I just don't buy the premise that the ERP should be the ultimate enforcer. Let me tell you why.
Okay, go ahead.
You're assuming that forcing an ERP to handle completeness is as simple as, making a couple of fields mandatory on a screen. But we're dealing with incredibly complex, jurisdiction-specific rules that change constantly.
They do change, yes.
Right, and ERP systems were built and optimized for internal operational processing. They manage inventory, they calculate payroll, they track ledgers. Asking the ERP to also handle global compliance, it's like asking a factory's engine room to also serve as the customs checkpoint for 50 different countries.
But if the engine room is producing the goods,
The engine room's only job is to keep the gears turning, your internal operations. If you force the internal mechanic to also check passports and border requirements for 50 different countries every time a gear turns, the whole factory just grinds to a halt.
well, I don't know if I'd say it grinds to a halt.
It does. Think about the specific country scheme as mentioned in our material. You have UBLTR for Turkey, you've got Fattura PA for Italy, KSEF for Poland.
Right, highly specific XML formats.
Exactly. These aren't just minor field additions. They are entirely different XML structural expectations. So trying to hard code every new global compliance requirement into the core ERP is a recipe for operational paralysis.
I see.
The only viable strategy is externalizing that logic into a canonical mapping layer. You let the ERP do what it does best, and you handle the 50 different customs checkpoints in the agile layer.
Look, I see why you think that separating the duties creates agility. But let me give you a different perspective on what actually happens to the data in that scenario.
Okay.
I am not suggesting the ERP needs to natively generate a Polish KSAF XML file or an Italian Fattura Piedu document, but semantic inconsistency is the silent killer here.
How so?
Well, let's walk through a tangible scenario. A salesperson closes a deal, and the ERP generates an invoice. But let's say it's missing a specific regional delivery address code required by that country's tax authority.
Okay, pretty common scenario.
Right. So your external canonical layer, this supposed universal translator in the middle, it intercepts the data. What does it do? It cannot interpolate a missing physical reality. It cannot guess where the truck is going.
Well, no, it flags it. It uses the mapping rules to identify the gap.
But the data is already permanently flawed. Agility does not matter if the data you are routing is fundamentally incomplete.
It prevents the flawed data from going to the government, though.
But if the ERP does not throw an error and block the creation of that incomplete data right then and there, the transaction moves forward broken. The material clearly states that contextual completeness is enforced at the point of data generation, not consumption.
I understand the theory, but
If your beautifully agile canonical layer is just mapping a blank space, well, a blank space mapped universally is still a system failure.
you are severely underestimating the immediate existential threat of continuous transaction controls, or CTCs. If we tether all this validation to the ERP upgrade cycles,
Existential threat might be a bit strong, no?
not at all. Let's look at how governments are actually enforcing this right now. We aren't talking about the old days where you send a monthly batch report to the tax authority and maybe they audit you next year.
Right, it's real time now.
With CTCs, governments validate in milliseconds. Your system does an API handshake with the government server before the transaction is even considered legally valid.
Right, the environment has become entirely zero tolerance.
Exactly zero tolerance. And the consequence of non-compliance is immediate rejection. It doesn't get accepted with a little warning note, it gets rejected outright.
Yes, that is true.
So an invoice that isn't machine-readable to the government's exact, up-to-the-minute specification cannot be legally issued. The truck literally cannot leave the warehouse. Payments cannot be collected.
Which is disruptive, absolutely.
Highly disruptive. In this hyper-aggressive environment, your validation mechanism must be an external compliance layer that updates its rules in total isolation. If the Polish government updates its KSAF schema on a Tuesday, I can update my external canonical mapping layer on a Wednesday without touching the underlying ERP. If I have to wait for a 6-month ERP configuration cycle to build in that new rule, the business cannot legally operate in Poland on Thursday.
I'm not convinced by that line of reasoning because I think you're treating the symptom rather than curing the disease.
How is keeping the business running legally just treating a symptom?
Because while the external compliance layer is the mechanism that submits the data and handles the API handshake, the principle of validation at source dictates that the business rules must be known when the transaction is created.
In a perfect world, sure.
Let's follow your Tuesday-Wednesday scenario to its logical conclusion. The ERP generates the transaction on Thursday. It flows to your agile middle layer. The middle layer checks it against the new Polish rule, finds it lacking a newly required data point, and what happens?
It rejects it internally back to the business user to fix, rather than failing at the government level.
But the business process is already broken. Bouncing transactions back and forth between a middle layer and the ERP for human correction, that is the exact manual intervention this entire transformation is supposed to eliminate.
But at least you're not getting audited by the Polish government.
The compliance layer did its job by catching it, sure, but the architecture failed because it allowed the creation of invalid data to begin with. You've basically just built an error loop.
I wouldn't call it an error loop.
It is. A model in the middle cannot compensate for bad architecture at the source. The ERP must know the rule.
An internal error loop is vastly preferable to the alternative. Look, if the ERP is the ultimate arbiter, and it hasn't been updated yet because legacy systems move like molasses,
They can be slow, yes.
the ERP confidently generates an invoice it thinks is perfectly valid. It sends it downstream, the external layer just acts as a dumb pipe, and the government rejects it. And a government rejection can trigger an audit.
True.
I would much rather my canonical layer act as a protective shield.
It updates its definition of what machine-readable means for a specific jurisdiction overnight, catching the error internally without requiring a massive, risky IT project in the source system.
But we are trying to achieve a state where automated systems work seamlessly without humans having to manually patch the gaps every morning.
Of course.
And that actually brings us to the ultimate strategic multiplier discussed in the material, which is enterprise AI deployment. Let's expand our scope beyond just surviving government tax audits.
Oh, AI is where the value actually compounds, yes. I think we can both agree that if you solve the machine readability problem, AI is the reward.
Precisely. But the material makes a profound point here. The primary failure mode of enterprise AI projects is not insufficient algorithm sophistication. It is bad data architecture. Let's look at how AI actually breaks down. Models trained on inconsistently structured, semantically ambiguous data generate entirely unreliable outputs.
Yeah, hallucinations.
Exactly. If we want an AI model to act as an autonomous finance agent, let's say to automatically approve million-dollar vendor payments, the source systems must provide structurally predictable, XML-based precision from the start.
Right, but
AI cannot handle semantic ambiguity. When it hits a null value, or a field that means two different things, it hallucinates. If we allow ERPs to produce operational data that only somewhat approximates reality and rely on your middle layer to clean it up, we're just feeding the AI sophisticated hallucinations.
well,
The garbage in, garbage out reality dictates that the ERP must be rigorously disciplined.
that's a compelling argument in theory, but have you considered where semantic consistency actually comes from in the real world?
From the source data?
You're arguing that the ERP provides the foundational truth. But in a multinational enterprise, you don't have one ERP. You have 5 or 10 or 50.
Which is a reality for most enterprises, yes.
You have systems acquired over decades of mergers. An SAP system in Germany and an Oracle system in Japan do not share semantic consistency natively,
They share basic financial concepts.
but not machine-readable consistency. Let me give you a specific example. Take a field labeled tax amount.
Okay.
In the German system, that field might be programmed to be inclusive of local duties. In the Japanese system, tax amount might be exclusive of local duties.
Right, a structural discrepancy.
If you just feed that raw ERP data to an AI model, the AI sees the column tax amount and assumes it means the exact same thing everywhere. It ends up underpaying a government by 20% and triggering a massive legal crisis. Sure, but the ERPs cannot provide universal semantic consistency because they speak different regional dialects. That consistency is actually provided by the canonical data model at the orchestration layer.
But again, the canonical data model is just a map. It's a routing mechanism. It doesn't originate data.
It standardizes meaning. A canonical data model is essentially a universal translator. It takes the different languages of those 50 proprietary database formats and turns them into one standard payload.
Yes, mapping.
A field only gains universal meaning across geographies and time periods when that centralized canonical standard translates it. The canonical layer says, regardless of what the German system or the Japanese system calls this, in our enterprise architecture, tax amount strictly means X.
I see the value in that, absolutely.
The intelligence, the actual semantic truth that the AI relies on is synthesized in the middle, not at the origin.
I will concede that the map once use everywhere principle is a brilliant approach for routing and structural transformation.
Thank you.
But you cannot map meaning that was never captured. Let's go back to your Japanese Oracle system.
Okay.
If that legacy system never recorded whether the tax was inclusive or exclusive because its internal 1990s process didn't require it, your canonical layer isn't translating. It's guessing.
Well,
And an AI built on automated guesses is a massive liability.
It maps the known variables and flags the structural deficiencies without requiring you to rip out the Japanese system entirely.
But the design choice must be to configure those source systems to enforce downstream completeness. The material is very explicit here. These are architectural design choices, not just, software subscriptions.
They are significant choices, yes.
The system that generates the data must be fundamentally designed to produce complete records. Yes, it is incredibly hard. Yes, upgrading legacy databases takes time and capital.
A lot of time.
But organizations that invest in that upstream discipline are building their AI and compliance platforms on a foundation of concrete rather than sand. If you rely on the middle layer, you are always one unmapped variable away from a catastrophic AI failure.
And I would counter that organizations building canonical orchestration layers are the ones actually deploying AI today, rather than waiting for a 10-year ERP harmonization project to finish before they can even start.
Agility is important. I won't deny that.
We are talking about building tomorrow's infrastructure. Every new compliance requirement, every new autonomous AI agent operates on data that is already in the right format, because the middle layer handled the massive transformation overhead.
The source material warns us clearly. Human-readable data is for humans, and machine-readable data is for the intelligent infrastructure. I maintain that this infrastructure is simply too vast, too global, and too fast-moving to be permanently anchored to the rigid internal logic of a transactional database.
This tension is exactly why this debate is so critical for technology leadership right now.
Absolutely. If I am summarizing my position, based on the material machine-readable by design is an architectural property. It requires unforgiving structural and contextual discipline at the very point of data creation. We cannot bolt on completeness downstream.
Right.
If the ERP doesn't demand the data, the intelligence doesn't exist, and neither AI nor global compliance platforms can function without human intervention.
And to summarize my view, true strategic readiness requires an agile, abstracted, canonical architecture, relying on source systems to keep pace with the relentless millisecond speed of global continuous transaction controls and evolving AI data needs is a strategic error.
It's a fundamental difference in philosophy.
It is. The canonical layer provides the semantic consistency and the real-time regulatory translation necessary to operate securely in a machine-driven world.
Yet, despite our divergence on exactly where this control layer must sit, there is a profound point of convergence here.
I think so, yes.
We both entirely agree on the core premise of the text. Relying on PDFs, bespoke integration code, and downstream human intervention is an existential risk. The days of looking at a screen and hoping human-readable data is close enough for the machines, those days are over.
Completely over. If you're a CIO or CFO listening to this analysis, the continuing tension lies in how to architecturally balance the rigidity required for absolute data completeness with the agility required for global regulatory survival. You simply cannot ignore either side of that coin.
Exactly. As tax authorities and AI agents increasingly operate at machine speed, evaluating the mechanical reality of your own organization's financial data architecture is paramount. Because if your digital data is just a high-resolution photograph of a cloud, the machines are going to look right past it. Thank you for joining us, and we leave it to you to decide which architectural layer ultimately holds the key to true machine readability.